Hey everybody, I'm going to give you the next 4 pages of the evolution packet. In a second, I'm going to start sharing the screen and bring up a PDF of these next 4 pages, and I'll read it to you and try and help you to get through some of the questions and figure out what to highlight, etc. So without further ado, I'm sharing right now. Okay, so this is page 1. I'm going to kind of move down through this quick and just tell you, give you a little basics about what you should have understood, right? Is that all life is very similar. We all share a lot of common traits. And then page 2 talked about how, although there are similarities, life is very, very different from one another. And we know this because we see so many different things and these different environments, these different biomes, tundra and taiga and rainforest and grassland. These have sort of pushed species to evolve to best fit their environments. So that's page 2. Things are very different, even though they share a lot of commonalities. And then we start talking about which species are most similar to humans. And we had you go through and check out some of these cladograms and graphics and things like that and try and interpret them. Some of you have been doing a really great job with these, so thanks for doing that. Page 4, which is the one that you finished with, gave you the story of Charles Darwin and how Charles Darwin took that voyage about 5 years and collected lots of information and really learned that these major things, right? That only the members of each species best fit for the environment will survive. So only those that are best fit for the environment are going to pass down their genes, are going to live long enough. So this means, like for cheetahs, right? Imagine a population of cheetahs, right? We've got some are faster than others. Those that are faster are more fit. Okay, this is called survival of the fittest. Only those that are best for the environment are going to survive and pass down their genes. And so only some members are going to pass down their genes to the next generation. So the second generation is a little bit different. It's going to be a little bit faster. And this has just been happening in all those different environments that we talked about in page 2. All those different environments are going to cause living things to end up different from each other. And this is evolution. And the Earth has been around for about 4.6 billion years, which is a really, really, really long time. So that's a lot for all these different millions of species. So let's jump into page 5. Page 5 is preventing some student misconceptions about evolution, right? That means like stopping students from getting sort of the wrong idea, okay? The first thing is that individuals cannot evolve. You can't evolve, I can't evolve, individuals don't evolve. Remember, this is a process that happens to a whole population. So we've got lots of different organisms and some survive and they pass on their genes, and those ones that don't survive, that means they die. And so the next generation is just going to look like the individuals that were successful and were survived. And so when a caterpillar changes into a butterfly, that is not the caterpillar's evolution. When a tadpole changes into a frog, that is not the frog evolution. That is something called development. Specifically, that's called metamorphosis. When an individual changes over its life to a big amount, really changes its whole body. Humans can't do the metamorphosis thing, but we do develop, right? We do end up growing facial hair if you're a male, and that allows you to start to have bodily changes so that way you can reproduce. And this is development. This is not your evolution, okay? Evolution is a process. This is big, and we just talked about it. That happens to a whole species over generations. So it has to happen over lots of time, and it has to happen over those generations, we're talking about some members surviving and other members dying off. And so the next generation is different. It has the characteristics of only the individuals that survive. Okay, that's evolution. Evolution cannot happen to individuals. So like Pokemon, where the individual changes over its life, you know, it gets experienced and then turns into something with wings now. No, that's not evolution. That's not real. I know you know that, but that's a good sort of like start of how a lot of students get, you know, like this idea that individuals changing is evolution, and that's not right. That's not how evolution happens, okay? So that's the first one, right? Individuals can't evolve. The second thing is that evolution is happening, even though it's hard to see it happening in humans in our own species. So evolution is hard to observe in species that take longer to have babies. We call that the next generation, right? It takes about 25 years for humans to really grow up and create the next generation of organisms that can reproduce themselves. Bacteria and really simple animals, they can reproduce very fast. You know, I'm breeding these crickets, and the crickets I'm able to make new cricket adults in about a month, a little more than a month. And so that's crazy fast compared to how long it takes humans to have the next generation. You know, humans can't make babies and have those babies grow up in a month. That would be insane. You know, we are much more complicated, so it takes us longer to, you know, have the next generation come up and become adults. Okay, and so because of that, our evolution takes a long time, and so it's sort of hard to see the evolution of humans. It would be much easier to see the evolution in crickets or in bacteria or in worms or something that reproduces very quickly, where we can tell which ones are living and which ones are dying and how the population has changed over those generations, right? That's what evolution is. That's what I keep telling you. We also have technology that keeps us healthy and safe from many dangers. You know, evolution happens by natural selection. Nature kills off organisms that don't fit with the environment, and those that survive are usually different from those that die. So does this really happen with humans? Does the environment really end up killing a lot of humans that we see? No, right? We have homes, we have medicine. You know, usually people die from an accident or from old age. It's much more random. We're not really hunted by anything. You know, if we were hunted by like tigers, and only the fast humans were able to outrun, you know, I don't know, we could not run tigers, but let's just say that the fast humans were surviving here, you know, then we would see sort of a pattern in the evolution of humans, because only the fastest humans would survive, and only the fastest humans would be passing down their fast genes. And so the next generation of humans would end up being faster than the generation before, and that would be some of our human evolution. But we don't have that. You know, we don't have to worry about getting hunted by things, so it's harder to see human evolution. Okay, all right, we don't have a lot of these predators trying to kill us that drives the evolution of humans to become, you know, faster or stronger or sneakier or whatever. Right? The third thing that students get confused about a lot is that humans did not evolve from monkeys. We are part of the ape family, and like other apes and other monkeys are sort of like cousins of us, you know, if in the bigger sense of like the animal kingdom, we're very similar compared to other animals like worms and things. You are obviously much more similar to a chimpanzee than you are to a worm. But although we share a lot of this DNA, we didn't come from them. Monkeys and humans, we share a common ancestor. And that means that there was something that existed before there were monkeys and before there were humans, in the way that we know of monkeys and humans now. You know, we have this, and I'm pointing this out, we have this common ape ancestor. And this common ape ancestor was not a gorilla. It was not a monkey. It had similar features to those. It looked sort of like it, but it wasn't any of those things. This was a time millions of years ago, before there were any monkeys that we know of that exist now, and before there were any humans. Humans weren't around. This was, 6.7 million years ago. We had this common ancestor, okay? So we are not monkeys. We did not come from monkeys, but we share a common ancestor with them, okay? So here are the questions, right? In a 5th grade science class, a student observes mealworms over time. After 3 weeks, the mealworms undergo changes and turn into black beetles. The student tells another student that his mealworms have evolved. So we just saw the mealworms changing over their lifetime into the beetles. Is this evolution? We should know that this is not evolution. So what would you say to the student to help them get rid of their misconception? So how would you explain that that is not evolution? So this is what you should highlight here. What would you say to the student, right? So this way you know how you're answering this. Please make sure that you're highlighting here, so I know sort of that you're following directions. And also, again, this is really helpful to highlight these answers. It lets us know that you're on the right track and that you're paying attention here. 18 says, evolution is an event that happens to populations over generations. The image below helps to explain this too. So based on the reading, why would it be easier to observe the evolution of the mouse population, right? Here's the mouse population. We've got some ancestors here, and they were different colors. And over time, the white ones keep dying off. And so over time, the darker colored mice are surviving more. And so we started out with this sort of grayish type mouse. The population was sort of grayish, and now the population ends up quite darker because of something that happened in the environment. Maybe there were more predators killing the white colored mice because maybe they didn't camouflage or blend in as much. So why would it be easier to observe the evolution of a mouse population than the evolution of a human population? So think about, again, how long it takes for the next generation, okay? So why would it be easier to observe is what you're highlighting there, okay? So 19, a student in your science class is known for saying hurtful comments to others. You overhear them calling their teacher, Mr. Murphy, a stupid monkey. With your knowledge of the evolution of humans, explain what you could say to the students so they aren't wrong again in the future. So if they called me a stupid monkey, they should know, because you know, that I am not a monkey and that my ancestors were not monkeys either. So explain that to them. Okay, page 6 talks about niches and the peppered moth. Okay, if you want to pause it and go back, now's a good time, so that way you can get done with page 5. So page 6 is niches and the peppered moth evolution example. So a species needs to find its place in the world, right? Everything has to find enough food and enough space and all the resources they need to survive. And if they are fighting over these resources and they're not as good at getting the resources, they are not as fit. And so they're not going to survive. And the other species will take over that niche. And the first species that wasn't as fit is going to go extinct eventually. Or they're going to leave that ecosystem and try and find a niche in a new ecosystem. And most of the time, they don't survive. So if a species exists in an ecosystem, then biologists say that the species is filling a niche. And we talked about what a niche was during ecology, right? It's like a species' role in the ecosystem. It's what they eat, and it's where they live, and it's how they live, all their behaviors, whether or not they're hunting at night or during the day, all the things that they eat, all the things that eat them, all their predators, that's part of it, right? Everything has a role in nature. We talked about that quite a bit. So every species competes. They fight for a niche because they're all trying to survive in the world. Think about how many different places there are in the world, right? We talked about that in page 2, all these different ecosystems. In a single forest, there can be thousands of niches, and so there's thousands of species. Think about all the different beetles in an ecosystem, or in a forest, all the different tree types and bush types in a forest, all the different mammals in a forest, squirrels and deer, and all the predator mammals, bobcats or mountain lions, maybe bears. There's so many different living things because there are all these sort of niches that they can hold, all these roles that they can play. Everything needs to find a place. So the earth is constantly changing. Even the rocks under your feet are moving. I hope you know that. The earth is changing. The earth even creates and destroys rocks every second. As the earth changes, each species needs to deal with the environment's changes. Many species end up going extinct when the environment changes a lot. But this opens up new species or new niches, and then new species can come about. And this is, how, the dinosaurs ended up dying, and then the age of mammals came about, and that's why we exist here. We wouldn't be around. Humans wouldn't exist if dinosaurs had continued to rule the earth, but a big change happened, and it killed a lot of the big dinosaurs, and that opened up a lot of new niches, a lot of new potential roles in the environment for things like mammals. And if that didn't happen, we wouldn't be here. So let me give you an example of this. In England during the Industrial Revolution, which is like the early 1900s, there was a big change in the environment. There's a lot of pollution that started getting poured into the air from all the factories. And so this changed the air. The air quality was really bad, and we were pouring lots of tiny little chemicals, and those chemicals were starting to pollute even the trees. The trees had this stuff called lichen on it. You see the lichen in here. And then there's even a peppered moth. Look at how beautiful the camouflage is in here. Here's the lichen, this green stuff behind it, and there's a moth right here, and they blend in really well when there's no pollution. But during the 1900s, in England, lots of pollution started getting pushed into the air, and that pollution got into the lichen on these trees. And so all those really, really well camouflaged, light colored moths, they started to stand out a lot more on the trees, right? The ecosystem got darker very quickly, and the moths usually land on the trees, and because they normally camouflage with the lichen. But the pollution was getting into the lichen, and the trees were becoming darker and darker. See the tree difference here and here? So this is pre-industrial revolution, and this is post-industrial revolution. The trees were much darker. So now the dark colored moths, the ones that are speckled, more dark colored, they started to survive more, right? The ones that are more of this color, they were more successful. And then these ones were less successful because they're lighter. And so because of that, we noticed a big change. In England, they noticed this big change. And they found a lot more dark-colored moths than light-colored moths because the light-colored moths were getting eaten. The dark-colored moths were surviving, right? Survival of the fittest. Dark-colored became more fit. And so they passed down their dark genes, and most of the next generations, little moth babies, were dark. And so there was this obvious change in the population of these peppered moths. And so this is a really good example of evolution, of natural selection, of nature selecting for one sort of type over another type because of the change in the environment. So hopefully that makes some sense to you, and you can go back if you need. We're going to talk about these next questions in page 6. The diagram explains that all three birds are able to coexist. They're able to live together in this tree because each species holds a different niche. So this warbler holds one niche. Maybe it eats a different food than the rest of these guys. Maybe it just lives in a different area, and so it doesn't need to fight over the food. But either way, what do we mean when we say, so explain what we mean by saying, that's what you're highlighting, the birds occupy different niches. So explain that in the box provided. 21, an Arctic ecosystem is warming faster than it has in 20,000 years. So the ecosystem is getting much, much, much warmer, and we know this is actually happening. We've got a lot of data to figure this out. And this change is obviously going to have an effect on the species that live there. The bears and foxes and wolves and seal and fish, all of these things are going to be affected by this change in the environment. So here's your question, right? Here's what you should highlight. What do you predict natural selection will cause first? So I'm just asking you to choose one or the other, and then to explain why. So you should highlight that too. So you're choosing one or the other and then explaining why. Again, this is why I want you to highlight, because I'm asking you to do two things, so you should be highlighting two things. Will more species go extinct first, or will new species evolve to fill niches first? And I'm going to ask you a question here. Can you have new species evolve to fill a niche if all of the niches are being held already? Think about that. Do you need to have the death first in order for evolution to have new species fill the niches? Or can you have new species come about before the niches are even opened up? Think about which one makes most sense, okay? And then I just ask you to explain your answer. So why did you choose it? Why did you choose one over the other, okay? Question 22 says, after learning about what happened to the peppered moth population, right? Explain why natural selection caused the moth species to become darker over time. So explain why natural selection caused the species to become darker over time. So that's what you should highlight there, right? That should make sense, right? Based on the information that you should have read up in this section here. So we got up to page 7, the evidence for evolution. And so really, Darwin created this idea of natural selection being the force that sort of causes evolution to happen, that nature just chooses some organisms over others. It basically, this whole thing is just basically about who lives and who dies. Which organisms are better fit for the environment, they end up surviving, and which organisms are not fit for the environment and they don't survive, they die off. And then those that do survive, they pass down their genes. And that's what Darwin figured out. It was a really simple idea, but it makes sense, and it has continued to make sense, and there's lots of evidence to support it. And so I'm going to talk about some specific pieces of evidence that we can find in the world today that's really strong support for this idea of evolution being driven by the process of natural selection, okay? So the first is that there's this thing that humans can do, and that's called artificial selection. And it's the exact same thing as natural selection, but instead of nature doing it, natural, it is artificial. Humans are doing it. So it's unnatural. We're creating things that nature created the things initially, and then humans sort of forced the evolution of them to become very different. So let me give you an example of how humans have sort of forced the evolution, have forced the selection towards a certain way. Dogs is a really great example. Dogs were only created because humans had been, they sort of accidentally created them because they just chose which wolves they liked the most and killed the other ones off. About 20,000 years ago, when humans were only had existed with these, with campfires and things like that, there were some wild wolves that would come around, and they smelled the meat that the humans had gotten from their hunts. And so the humans didn't like a lot of really nasty dogs being around the campfires. So the dogs that were nicer, that were more tame, those are the ones that the humans were allowing to eat more of the bones, and the really nasty wolves, the humans were killing more of those off. So what traits are successful there? It's not the crazy nasty genes or the crazy nasty traits that were successful for wolves around humans. In order to be around humans, it was better to have the trait to be more tame, to not be so nasty to the humans. That ended up being a beneficial trait for the survival of those wolves living near the humans. And so over time, over many generations, you only had the nicest wolves that were surviving more and reproducing more. So only the nicer wolves would survive and reproduce. And it got, this became such a common thing that eventually we had, humans had dogs actually in their camps, and they continued to do this process of killing the nasty wolves and allowing for only the nice ones to survive. And eventually we were able to, you know, once we started to have more civilizations, then we can choose dogs for traits that, for like cuteness, or to be fluffy, or to be really smart, or to help to shepherd, you know, sheep or something like that, you know. And so that's what we did, you know, things like pugs, like this little guy here, there's no way that they would have existed if nature had just run its course, and if humans didn't come in and basically create the pugs by just choosing the dogs with scrunchier faces, you know. These dogs, pugs have breathing problems and hip problems, like almost right when they're born. So there's no way that these organisms would have been able to survive in nature. There's no reason for evolution to push or to drive the dogs to look like pugs or to act like pugs, because it's not beneficial for their survival to be super cute. It's just a trait that we liked. And so we caused the evolution of dogs to have things that were not really natural. But we create other things too that are more helpful for our own survival. We artificially select a lot of fruit trees, and a lot of berry bushes and corn and cows and chickens and all of our farm animals and pigs. All of these things have been artificially changed. We have artificially messed with the evolution of all of these species because it benefits us to have bigger apples or fatter pigs or fatter chickens or cows with bigger udders. And so we have evolved a lot of different species for our own benefit. And that means that's great evidence that evolution actually exists, right? And so dogs are a really great example that evolution does exist, and it exists through this process of selection. In nature, it's called natural selection, and when humans do it, it's called artificial selection, okay? This is a video link to a Neil deGrasse Tyson video when he did the show Cosmos, and that explains the evolution of dogs from wolves too, but it's got some cool animations too. So if you want to check that out, go right ahead, okay? The next bit, homologous structures or homologous structures. Whenever you see this prefix homo, it means same, all right? Homologous means like from the same origin. So when you see like your arm bones, right? We've got one bone, that's your upper arm bone. We call it the humerus. The humerus is up in here. And then we have two bones. This is the ulna and the radius. We have two bones, and then we have a bunch of bones in here in our wrist. And then we've got some long bones here and some long bones here. And we actually find this similar pattern of one bone, two bones, wrist bones, and then sort of long bones. We see that pattern all across a lot of the animal species, a lot of animal species that are more similarly related to us. You know, a seal has a flipper, not an arm. But look, they had the same pattern. You see the pattern is sort of highlighted. They had this you know, shoulder bone, a single shoulder bone, like all of the other organisms here are shown do. And then they have one bone, and then another one bone, right? Just like an orange, and then two bones. You see the two bones? And check it out. I mean, a human, a dog, a horse, a bat, a bird, a seal, these are all pretty different organisms, but they all have the same pattern inside of their bones, even though they use these limbs for different things, you know. Bats fly, and seals swim, and birds fly, and horses gallop, and so we use them for different purposes, but if you look inside the limb, there's some similarities in structure. And what does that tell us? That tells us that we all come from a common ancestor that had that same structure. The same pattern, I'm reading some info right now. The same pattern exists in all of those different organisms. And this is evidence that we all share a common ancestor that actually had that bone structure. Before there were humans, dogs, horses, bats, birds, before there were any of these things, there was something that was a very basic animal, not as specific as all of these are to their environments. Evolution hadn't taken as much time yet, right? This was millions of years ago, hundreds of millions of years ago. But there was something that had that single bone, couple of bones, wrist bones, and then some longer bones. And they were really successful with that structure in their limbs, more successful than other structures. And so they are the ancestors to all of these organisms. So we're pretty similar, right? We share a lot of common things, even if it doesn't look like that on the outside. Sometimes things like the bone structures and bone patterns will tell us quite a bit about how we're common to other living things. The fossil record is another little bit of evidence for evolution. And that's just really basic, and this diagram does a pretty good job of showing this, is that when we talk about being like the older rocks, the rocks that are buried deeper are older, right? They were the ones that settled millions and millions of years ago. And then over time, newer rocks settled on top, you know, and obviously the soil, I'm looking outside of my backyard, that soil is the most recent. But if we kept digging down and down and down into the rocks, we would see layers of rocks that have been sort of stacked on top of each other over time. And so these are the most recent fossils, meaning they're the newest, and these are the oldest at the bottom, right? The youngest is at the top, the oldest is at the bottom. Excuse me. And then what they're trying to tell you, and what we see, is that all over the world, we find the same pattern in the fossil record. We find that in the very, very old rock layers, that the organisms, the fossils we find are very simple. And then in the newer rock layers, the fossils that we find are more complicated. They're more complex because those species, they are newer. And so there has been more millions of years of evolution. And so they're more specific for their environment. They're more complicated because there's been just more and more generations of evolution behind them. And so they're more complicated. They're usually more similar to the things that exist today, the newer fossil layers. And we find this all over the earth. And so that's evidence that evolution is a thing, that it's been happening to the earth, and it's been happening to life on earth over many millions of years. And because of these different environments, and because of time, and how just those that are most fit for the environment pass down their traits, this process has created many different species that are specialized for their environment. In this case, having these legs on these sand dollar looking things, that seems like a beneficial trait, I guess, for this type of organism. Okay, so I know that might have been a little bit confusing for you, so if you want a little bit, I mean, there's so many videos on YouTube, so check it out here about the fossil record. I'm not going to go into a lot of detail about this because I put it in there just because I thought people would be interested at how life has changed over time on Earth, but also like how long were the dinosaurs here and what has happened to the Earth since its beginning. So that's what this diagram shows you. It sort of crushes the whole age of the Earth and puts it into a 24-hour period. And so if you did that, if you took the whole age of the Earth and put it into this little 24-hour period, you'll notice that humans, let's see if I can get it here yet, humans only come about almost at the very, very, very end. We have not been around for long. In this case, in 24 hours, if the Earth has been around for 24 hours, we are at the 11th hour, 58th minute, and 43rd second, basically meaning we've only been around for 17 seconds out of the Earth's 24-hour history. So humans have not been around long at all. Dinosaurs came about just before 11 o'clock. So dinosaurs, really, they existed from 300 to 65 million years. So they ruled the Earth for a little over 200 million years, which is a long time. But again, compared to the whole history of the Earth, it's not super long. I also want you to notice that this whole big period of time, like half of the time, like 12 hours of time, the Earth existed and there was no life that was bigger than single-celled organisms. So basically, the Earth was just with bacteria. It didn't have anything more complicated than bacteria on it for about half of the time on Earth. So about 2 billion years, which is a crazy long period of time. About 2 billion years, the Earth existed without any animals or any plants or anything complicated that we would see in the fossil record now. The Earth was just full of bacteria, and that bacteria was evolving and growing more complicated, but it was still just single-celled bacteria. So that's kind of interesting, kind of weird to think about. Okay, so page 7, here's some questions for you, right? Using artificial selection, humans are controlling the evolution of dogs, cats, cows, corn, beans, fruit trees, and many, many other species. Humans do this so we can make other species have traits that benefit our own species, right? We want to sort of force the evolution of other stuff so that way we can have more food or more medicine or whatever. So provide one example of artificial selection other than dogs, because I talked about dogs already a lot. So you can choose any of these that I gave you, and then explain the difference between artificial selection and natural selection, which you should be able to do by now, okay? Question 24 it gives you the same, or at least a very similar image that I gave you before when we talked about homologous structures. And it shows that same, here's one bone, two bones, bunch of bones, and then the finger bones. One bone, two bones, bunch of bones, and here's some bones. This is for a dog, so they don't have fingers, but again, the same pattern exists. And this is evidence that we have I'm looking for an answer that has 2 words. We all have a common something, okay? So I'll give you that first word, it's common, right? So make sure that you fill in that in the space. The last question for pages 7 are explain the difference between the fossils found in very old rocks and the fossils found in the layers that are closer to the surface. So I talked about that just a minute ago. The fossils found in deeper, older rocks, what kind of fossils do they have? Like, how are they different? How are those fossils different than the fossils that we find in some of the top layers? So which is more complex and which is more similar is what I'm asking, all right? Let's go to page 8. Page 8 is the last page, and we're going to talk, or at least I'm going to explain to you how this New York State lab, this is a lab that is given to us by New York State, and it's about the evolution of birds. And it's really just to sort of give you an understanding of how different birds would exist in different environments based on the food that's on that environment, right? So it's a lot like Hungry Hungry Hippos. This is also a state lab that, and that means you have to have this under your belt. You have to have evidence that you've done this lab. Otherwise, you can't take the state test. So it's really important to go through this lab, and something that's mandatory in order to take the New York State Regents. Okay, so here's some objectives for the lab, and I actually asked you in the first question to tell me what the objectives are in your own words. The objectives are to show students how different environments affect the survival and evolution of a species, right? And you should have a good understanding of this by now after going through all this evolution stuff. A different environment will change the evolution of a species. If you're in an environment that has that is very, very, very warm and mostly just green grass, then you're going to have species that are very, very different than an area that is colder that only has snow. You know, only different organisms are going to be able to survive in different environments, and that's going to, you know, force the evolution of the species a certain way, or it's going to kill them off. So the second objective is to show students how natural selection works, which is just more details about how of the first one, right? That there's variation among the birds, so there's different birds there, and then they're going to compete for these resources, and they're going to fight over the food, and not all of them are going to survive. And this will lead to changes in the bird population over the next generation. So the whole setup, again, it's like Hungry Hungry Hippos, where everybody is scrambling for the food, but it's unlike Hungry Hungry Hippos in that each bird is going to have a different beak. You know, and the hippos game, all of the hippos are the same, they're just different colors. In this one, you're each going to have sort of different different tools, and you're going to be pretending that you're a bird. And so some people might have chopsticks, other people might have a little pliers, other people might have forceps, that's like tweezers, other people might have little binder clips, and you're going to represent a bird, okay? Each bird has a different beak, and that's going to be a different tool, and each table around the room is going to be a different island, and that's going to represent our different environments. And so some islands are going to have more seeds, and other environments, maybe they'll have more worms, bugs, whatever I've set up around the tables. And so your goal is to compete with the other birds. You're going to use your little tool as your beak, and it's the only thing that you can use to get your food. And once the food runs out, we're going to gather the data. We're going to count up which birds, count up all the food that each bird got, and then we're going to sort of figure out which beak type is most successful at which table, at which island. And that's going to give us some idea about which birds are most successful getting different types of food, because that's how it sort of works in the real world. If there's, you know, birds with different beaks, and some of the birds can't get the worms, and there's lots of worms in that environment, those birds are going to die off. Over time, they're going to become less common. Eventually, they're going to go extinct from that area. And that's just how nature works. That's how natural selection works. And that's how we end up with the way that the world is. Okay. So again, I'll just read this for the last bit. If a species is most fit, that means that they're successful at getting the food in their environment, then they would survive more. They survive more, they reproduce more, and then they become the dominant species of bird in that environment, right? And competition is just going to keep happening every single day. Every day I'm looking out in my backyard, there are birds fighting over resources, and those that are most successful, they're going to become more common next year, when, you know, because they're going to be surviving and they're going to be making more eggs. So let's check out the questions and get done with this, okay? Explain the objectives in your own words. So that's what you're highlighting. Explain the objectives, put them in your own words. It should be pretty easy. You're gonna, this is really just to model evolution by natural selection and show you what natural selection is and how it works. This next one says, using the diagram, which finch species would compete with the woodpecker finch for food if they both lived in the same ecosystem? And so really, I want you to check out the center here. The center tells you the type of food that each of these birds goes after. So the large tree finch and the small tree finch and the woodpecker finch and the warbler finch, they all eat animal food. See how it says animal food? This talks about what their bills look like, what their beaks look like, right? So all of these guys eat animal food, right? The warbler finch is the only one that only eats animal food, right? It says all animal food. These guys eat mainly animal food. So they might eat some seeds and things like that, but they eat mainly worms or bugs or that kind of thing. Whereas all of these birds, right? All these three and all these three, they all eat mainly plant food. And so if I put a medium ground finch that eats mainly plant food, right? Mainly plant food, medium ground finch. And then I put that in the same tree with a small tree finch that eats mainly animal food. They eat different types of food. These two birds can probably live even in the same tree because their niches are different. Even though their habitat is the same, they fill different roles in the ecosystem. One of them might eat the seeds, and then the other one might eat bugs that exist in dead parts of the tree, or who knows. So these two birds can exist in the same tree, and because they can fill different niches, they have sort of different roles in this ecosystem, okay? So I'm asking you which species would compete with the woodpecker finch, right? So check out the food that the woodpecker finch eats, check it out, and then think about another bird that would also compete with the woodpecker finch given the information in the center of this diagram, okay? So this last question says, based on the bar graph on the bottom of page 8, and I'm scrolling up now, here's the bar graph. So let's look at it for a second. It says adaptation bird beak type lab. So this is just telling us, right, the overall title, okay? This is about the lab. And here on this axis, this talks about the amount of food eaten. So here's how much food was eaten. And the bottom here says bird beak type. So we've got different bird beaks, and based on the different beaks, they're eating different amounts of food. And so if you check out clamps, birds with the clamp beak type, right? We're in beak type here on the bottom. The clampy beak types, it doesn't look like they were great at getting any of the food types. Let's check out forceps. Forceps, whoa, look at how many worms those with the forceps. Remember, forceps are like tweezers. If you don't know what any of these words mean, just do a quick Google search. It'll give you some images, no problem. So forceps, again, are like tweezers, and check out how many worms they got. They got a lot of worms. So we're going to keep that in mind. Chopsticks looks like they were good at eating seeds, right? Chopsticks are good for seeds. And then if you have a sort of a spoon type of a beak, then it looks like seeds and fruit you're really good at getting, okay? So let's check back to the question. The question says, which type of beak would be commonly found in an environment with lots of worms? So again, we're going to go back and we're going to look. All right, so which one was really great at getting worms? Well, the forceps one was great at getting worms, right? And so that means that the birds with the beaks that sort of were longer and thinner, that look like forceps, those are the birds that should be more successful in environments with a lot of worms. They're going to get more food, they're going to survive, they're going to reproduce. And like, let's look at chopsticks. What if a bird has beaks like really long chopsticks? Are they going to be able to get a lot of worms? No. So the birds with those kind of beaks, they're not going to be successful. They're not going to be able to survive and reproduce. And so those ones are going to end up dying off in that environment. and the birds with this beak type, they're going to be able to survive more. And then it says to provide data from the bar graph. So you're going to actually look at this and you're going to say, whoa, all right, so the forceps was my answer. The forceps beak type, they would be most successful. And then it says to use the data to help explain why. Well, we have to actually use the numbers from our graph here. And I look at forceps and I go up and I see that forceps ate 15 of the worms. So I can say that the forceps beak type would be most successful because they ate 15 worms, and they ate and look, we got to look at the other worms from the other things. The clamps only ate how many worms? Only 4 worms. The chopsticks only ate looks like 2 worms. The spoon type of beak only ate 6 worms. So nothing even comes close to the forceps that ate 15 worms. So that's what we'd actually have to say, that the forceps ate 15 worms, and then we could say maybe the next best type of beak was the spoon and only ate 6, telling us the other beaks were even lower than that. So you have to actually use the data, use the numbers that we see in the graph. You have to use the information that we're seeing in the graph here. This is going to be the best way to make sure that you're getting all the credit for your answer, because you're actually using information and data from the graph to help you out. Okay. So this is the end of the evolution packet. It's due again May 1st, so make sure that you are hitting submit on May 1st, and if you have any questions, as always, you can throw them in the comments here, or you can give me a Discord text, or send something up on Google Classroom. Okay, any of those, please make sure you get in touch with me. I miss you all. Hopefully I'll see you soon.